Sairam dear children, welcome back to this session. This is the last part of this chapter. Today's session we are going to discuss about last class assignment solution. Next we are going to discuss about reactions of ethanol and ethanoic acid. Mechanism of action of soap, very important. Uses of soaps and detergent. Let us discuss about assignments of last class questions. Alkanes undergo only substitution reactions, but alkenes and alkynes undergo both substitution and addition reaction. Why? I hope you have answered this question. Please, if you have not answered this question, please note down. We know alkenes are saturated compounds. Means saturated compounds are nothing but having a single bond between the two carbon atoms, hence they undergoes only substitution reaction, not addition reaction. Addition reactions, we know what is addition reaction. Next, whereas alkenes and alkynes are unsaturated carbon compounds. Unsaturated compounds also contains double and triple covalent bond, hence they undergoes both addition and as well as substitution reaction. This is the answer. Next, how do you convert ethanol into ethanoic acid? We have discussed that is oxidation reaction. Ethanol is converted into ethanoic acid by a catalyst alkali KMnO4 or acidified K2Cr2O7, that is potassium dichromate. This is the reaction. Ethanol can be converted into ethanoic acid by oxidation and also by using catalysts, that is alkali KMnO4 and acidified K2Cr2O7. Next, compare physical properties of ethanol and ethanoic acid. We know what is ethanol and what is ethanoic acid. These are some physical properties. Next, what is hydrogenation? This is also very simple definition. Hydrogenation is the process of converting liquid oils into solid saturated fats by passing hydrogen gas in the presence of, very important, in the presence of nickel. As a nickel, very important definition this is. And today's class we are going to discuss about reactions of ethanol. Before that, please note down these reactions. You have to note down here itself, because we have to practice. All these are nothing but we have to practice the reactions, then only we can learn these things. First, let us discuss about reactions of ethanol. Reaction with sodium, very important, please note down here. When ethanol means C2H5OH, alcohol, reacts with sodium, it forms sodium ethoxide and hydrogen gas is liberated. This is one of the reaction. Please note down this reaction. When ethanol reacts with sodium, it forms sodium ethoxide, very important, and hydrogen gas is liberated. Here see, note, very important, please note down this reaction. The hydrogen atoms in OH of ethanol, this hydrogen atom in OH, this is reduced to hydrogen gas. This is reduced to hydrogen gas, whereas sodium, this is oxidized to Na plus. This is the reaction. Once again I will repeat, hydrogen atoms in the OH of ethanol, this hydrogen atom in the OH of the ethanol is reduced to hydrogen gas. Reduction means addition of hydrogen, removal of oxygen. Next, what is oxidation? Addition of oxygen, removal of hydrogen. Sodium is oxidized to Na plus. This is the important reaction. Please note down. They may ask, convert ethanol into sodium ethoxide, then you have to write this equation. Next, Dehydration of second reaction, that is the dehydration of ethanol. Dehydration is nothing but removal of water molecules. Heating ethanol means alcohol at 443 Kelvin with the excess of concentrated sulfuric acid. Concentrated sulfuric acid is the king of an acid. When ethanol is reacted with concentrated sulfuric acid at 443 Kelvin, it results in the formation of ethene. Alcohols are converted into alkene. This is a reaction. See here, this is a reaction. Ethanol is converted into ethene and water molecule. See here. This OH and one of the hydrogen atom is removed. Then it forms CH2. See, if we remove hydrogen atom from here, it forms CH2 double bond. If we remove OH, it forms CH2. This is nothing but ethene and water molecules. This is the reaction. Here you have to note, concentrated sulfuric acid act as a dehydrating agent. Dehydrating agent means nothing but removal of water molecules. That is nothing but dehydrating agent. This is the reaction. Please note down. Next, now we are going to start with the reactions of ethanoic acid. First reaction is esterification, very important reaction. Please note down. Ethanoic acid means carboxylic acids reacts with absolute ethanol, means alcohol, in the presence of an acid catalyst. Any acid, HCl or H2SO4, it forms an ester. I will show you. This is the reaction. This is the ethanoic acid. See here. This is ethanol. In the presence of H2SO4 acid catalyst, it forms ethyl ethanoate. It is nothing but ester. See here. OH and here H is removed to form ethyl ethanoate. This is the reaction. This is the reaction. Here also indirectly, here also H2SO4 act as a dehydrating agent. Here water molecules is removed. See, that is the water molecule. Once again I will explain. From here, from ethanoic acid, OH is removed. Here from ethanol, hydrogen atom is removed. Then it forms ethyl ethanoate. Ethyl ethanoate is nothing but an ester and water molecules. You have to note, esters are very important. Esters are sweet smelling substances used in perfumes and as flavoring agents. This is very important. Esters are nothing but they are sweet smelling. This is the reaction that we can carry out in our laboratory. In chemistry lab, we can carry these reactions. Next reaction. Next reaction, this is very important. Reaction with base. Base means NaOH. When ethanoic acid reacts with base like sodium hydroxide NaOH to form salt. Salt means sodium ethanoate or sodium acetate and water molecules. You have to remember, ethanoic acid reacts with any particularly base, that is sodium hydroxide. It forms sodium ethanoate or sodium acetate. This is the reaction. This is the reaction. Please note, ethanoic acid reacts with sodium hydroxide. It forms, what is this? Sodium ethanoate or sodium acetate and water molecules. This is the reaction. Note down. This is very important. This is used as a soap. Next we are going to discuss about soaps and detergents. This is very important. Please note down. Again I am repeating this once again. Ethanoic acid reacts with what? Any base, that is particularly sodium hydroxide. It forms sodium acetate and water molecules. Here hydrogen atom is removed, here Na is removed, then it forms sodium acetate CH3COO minus Na plus. Next reactions, continue with reactions of ethanoic acid. This is also important. Please note down all these reactions, you have to note down. If you note down, if you practice once or twice, then it is easy for you to understand these reactions. Reactions with carbonates and hydrocarbonates. Remember, ethanoic acid reacts with carbonates and hydrocarbonates to form same, that is salt, carbon dioxide and water. The salt produced is commonly called as sodium acetate. Very important reactions. This is the reaction. This is about sodium carbonate. When ethanoic acid reacts with sodium carbonate, it forms sodium ethanoate or sodium acetate, where carbon dioxide and water molecules are released. Similarly, same reaction, but it is sodium bicarbonate. For above reaction, it is sodium carbonate. What is the formula? Na2CO3, that is sodium carbonate. What is the formula here? For sodium bicarbonate, NaHCO3. There is a difference. You know, in acids, bases and salts, we know the difference between sodium carbonate and sodium bicarbonate. We have already learned the uses of sodium carbonate and also sodium bicarbonate in acid, bases and salts chapter. When ethanoic acid reacts with sodium carbonate, forms sodium ethanoate, carbon dioxide and water molecules. Similarly, ethanoic acid reacts with what? Sodium bicarbonate. It forms sodium ethanoate, CO2 and water molecules. You have to remember here, you have to remember this reaction, that is the reactions of carbonates and hydrocarbonates. Please note down the reaction. Next reaction is saponification, very important reaction. Please note down as very definition, the process that involves conversion of fat, oil or lipid into soap and alcohol by the action of heat or in the presence of aqueous alkali or in the presence of base, that is NaOH. Here nothing but what is saponification? The process of conversion of fat or oil or lipid into soap and alcohol by the what? By the action of base, that is NaOH, or by the presence of aqueous alkali, that is NaOH. This is the reaction. Please note down, this is the reaction. In esterification, it forms ethyl acetate. Same, when an ester reacts with sodium hydroxide, it forms a soap molecule, that is sodium acetate and ethanol. Very important. In esterification reaction, the product formed is ester, that is ethyl acetate. This is the ester. When ester or when an ethyl acetate reacts with sodium hydroxide, it forms sodium acetate, that is the soap molecules, and ethanol, this is the alcohol, in the presence of heat or in the presence of a sodium hydroxide. When we heat this ethyl acetate in the presence of sodium hydroxide, it forms sodium acetate and ethanol. You have to know, sodium or potassium salts of long chain acids are called as soaps. Very important definition for soap molecule. We are going to for Soaps, this is a very important definition, that sodium or potassium salt of long chain carboxylic acids are called as soaps. This is the definition. Please note down that this saponification reaction. We know this is the esterification product, that is ethyl acetate reacts with sodium hydroxide, it forms sodium acetate and ethanol. Next we are going to discuss about soaps. Last part of this chapter is soaps and detergents. Very important for your exam purpose, because the action or mechanism of a soap is very important. What are soaps? What are generally soaps? Soaps are chemically the sodium or potassium salts of long chain carboxylic acids. They are the sodium or potassium salts of, very important, long chain carboxylic acid. They are long chain. Next, the synthesis of sodium or potassium salt of fatty acids by the alkali hydrolysis of fats is called saponification. How soaps are produced? Generally by saponification reaction, soaps molecules are produced. Soaps, what are the properties? Soaps do not form foam, nore barodilla yadralli odd water alli, do not form foam with odd water. Next, soap increases the hardness of water. Very important point. Soaps do not form foam, with odd water. Soaps increases the hardness of water. Next, do not form foam with hard water. Please note down these points. Next, let us discuss about mechanism of action of soap. Very important. Please understand this concept. Very important for your exam purpose. First point, very important, please note down. The ionic end of soap interacts with water. Interacts means there are two parts. One is ionic end and one more is carbon chain that interacts with oil. That is hydrophilic and hydrophobic. We'll discuss what is hydrophilic and hydrophobic later. First point is the ionic end of soap molecules always interacts with water, whereas the carbon chain interacts with oil, means hydrophilic and hydrophobic part. We will discuss what is hydrophilic and what is hydrophobic. Next, second point, soaps form micelles in water. When we know how difficult, when our clothes are dirty, how difficult for mothers to wash, you know, because they are very difficult to wash. So, next, second point, remember, soaps forms micelles in water, a structure in which one end of molecules is towards the oil droplets, means towards the carbon chain or hydrocarbon, while the ionic end faces with water. In a micelle structure, later we will discuss what is micelle, and there are two parts in a micelles, that is, one part is the hydrophilic part, one part is the hydrophobic part. This is the second structure. Second point is soaps forms from micelles inside the water, where it has two parts, one is hydrophilic part and one is hydrophobic part. Next, soaps helps in emulsification. Emulsification is nothing but removal of oil or fat into water. Emulsification, emulsikarana, in Kannada we call as emulsikarana. What is emulsification? Soaps, when we wash our clothes, we know how difficult, but this emulsification is nothing but removal of oil or fat into the water molecules, water. Next, this is very important, very important point, please note down. Soap micelles helps in cleaning by pulling out oil dirt into water, means these micelles try to pull out dirt in our set, if there is some grease or oil part, these missiles helps to pull out oils or dirt part into water. This is the mechanism. 4 points you have to write the this is the 4 points you have to mention. If they ask explain the mechanism action of a soap, you have to write these 4 points. This is nothing but this is the mechanism. Please note down. Next, how soap molecule forms I will show. This is the generally soap molecule. See, I said there are 2 parts, one is ionic, one more is hydrocarbon. Ionic always, that is hydrophilic, that is moving towards the water molecule, water attracting. One more is hydrophobic. I said in a missile there are 2 layers, 2 parts, one is hydrophilic part, one is hydrophobic part. Hydrophilic part means moving towards the water, water is attracting. Hydrophobic, moving away from water. Hydrocarbon, that is hydrophobic and hydrophilic. This is the soap molecule structure. Please see. Next, how missiles formation. This is soap solution. Solution means soap grease particle. If our shirt is have some grease particles or oil particles, how this soap? These soaps will react and they will form missiles. These missiles helps out to remove these oil particles. This is nothing but soap missile formation. This is the action. Please note this, very important. Next, structure of missile. Very important. I said there are 2 parts, one is the hydrophilic and one more is the hydrophobic. If you remember these 2, hydrophilic, philic means move towards the water, hydrophobic move away from the water. What is missile? Missiles is a monolayer of aggregate of soap molecules formed due to chemical structure of soap molecules. It is a monolayer, onde layer. Example I will write. This is generally structures. It has 2 parts, one is hydrophilic. This is the hydrophilic, head region is hydrophilic. This tail region is hydrophobic. Next, in a missile sphere formed in water, one is hydrophobic, carbon chain face away from water means it repels from water. The hydrophilic always ionic phase with water means which attracts with water. Missiles are nothing but a monolayer aggregate of soap molecules formed due to chemical structures of soap molecules. That is the definition. In missile there are 2 parts, one is hydrophilic. Hydrophilic means move towards water. Hydrophobic, move away from water means which is repelling away from water, which moves towards oil part. This is the structure of missile. Very important. The structure of missiles were very important. Next, detergents. What are detergents? Simple definition. Detergents are chemically ammonium or sulfonate salts of long chain carboxylic acid. For soaps they are sodium or potassium. For detergents they are chemically ammonium or sulfonate salts of long chain carboxylic acids. Properties of detergents, very simple properties. They form foam even in odd water, whereas soaps does not form foam in odd waters. Here they form foam, nore, in odd water, hence useful when cleaning done with odd water. Then they can cleanse our clothes properly in odd water. Detergents can increase the softness of water. Soaps increases the hardness of water. Here detergents increases the softness of water. Next, they do not form micelles during the cleaning process. They do not form micelles during the cleaning process. Soaps forms micelles during the cleaning process, but here detergents do not form micelles. Please compare between detergents and soap and write the differences. This is for your assignment. Next, uses of soaps and detergents, general uses. Detergents are usually used in the preparation of shampoos and the products of cleaning and stain removal. This is general use. Shampoos or washing purpose. This is the general uses. They are found in the products that been used as personal hygiene, cleaning of surfaces, laundry and dishwashing. These are general uses of soaps and detergents. We always use this cleaning for our vessels, clothes, or we use it for personal hygiene, for having face wash, for having bath, we use some soaps. These are general uses of soaps and detergents. Today's class we have discussed about the reactions of ethanol and the reactions of ethanoic acid, and later we discussed about the reactions of ethanoic acid, that is the esterification reaction and saponification reaction. Then we discussed about what are soaps and the mechanism or cleansing action of a soap, and we have discussed about detergents. For assignments, explain the mechanism of cleansing action of soap. Second question, how do you convert ethanol into ethene? Very important. Why does micelle formation occur when soap is added to water? This is very important. This you have to think. Explain esterification and saponification reactions. These are the assignments for today's class. Today we are going to complete this chapter. If any doubts, if there are any clarification, we will see in our next class. By saying this, we conclude. Jai Sai Ram. Thank you.